Hello, everyone, and welcome to another episode of Live at Epiphan. It is Thursday at 3 o'clock, I believe. Uh, and hopefully everyone has a better track of dates and times and all this continued pandemic stuff than I do, because I know I'm losing track. Uh, but in any case, it is definitely Thursday, and we are here, Dave and I, to talk about live streaming and the future of it and some of the protocols. Excuse me. Wow. I'm dying over here. Anyway, apologize for that. I'll try and recover. We're talking about the future of live streaming and specifically some of the protocols that are leading the charge into the future. And of course, we're very excited to discuss those because those of you who may have joined us earlier this week when Dave and I revealed that these protocols are coming to the Perl family of encoders, this is a little bit of a deeper dive as to what that means for the future of live streaming. So, what does that mean in terms of slowly but surely CDNs are shifting away from things like RTMP and towards some of these protocols? What are the implications for streamers and broadcasters in terms of the equipment they need to look at for future proofing, if you will? And then, of course, as I mentioned, we announced we're doing this to give you those options. And we want to clarify our area of focus a little bit and streaming it as an encoder to an ingestion point versus the distribution side, where as a viewer, you're pulling it down from the server. So as Epiphan, we're primarily focused on that streaming from an encoder to ingestion, and not so much the distribution side. So that's our primary perspective, just to be upfront about that. All of the protocols we're going to be talking about today are used from kind of both. So that's why it's important to think about it in those terms. So one of the first things we want to take a look at is which ones we're going to be discussing. SRT, HLS, also known as HTTP live streaming in long form, and MPEG-DASH, also known as DASH, dynamic adaptive streaming over HTTP, which is clearly way too much of a mouthful, so DASH will do. So those are kind of the three that we're going to be focusing on today. I'm sure some people may ask questions about codecs. That's kind of a different category. We're not really talking about that. And I saw some stuff recently about how YouTube is looking at codecs and certain bit rates and resolutions. And that's a whole other topic that maybe we'll address sometime. But anyways, hello to everyone in chat as well. I see a number of our regular viewers like Linda and Faithful Messer there. So everyone say hi in chat. And as usual, if you have questions for Dave and I, let us know. And I'm keeping an eye on chat. So the first thing, let's go do a little bit of a history lesson, I guess, Dave.
Yeah. So we know that, RTMP's been around a long, long time. So here we're far left of our chart here. Macromedia introduced this as a way to stream data in real time. And that was pretty innovative back in that time. And it was a proprietary thing that eventually they made public after being acquired by Adobe. But it's been a long time. It's a protocol that's been there for a long time. It served us well. But our kind of view of that protocol today is it's time to go. There's newer, better things coming along, and we aren't the only ones kind of expressing that view. We've got CDN partners and many others who are also kind of moving to newer protocols.
And there's a lot of reasons for that. As we move, this kind of talks about the dawn of streaming, and again, in summary, for people to remember, we kind of take something like YouTube for granted in terms of internet usage today, but that only started in 2007, really, as in a big way, 2005, and then for very earliest iterations. And of course, social media as we know it today, like Facebook, didn't start until 2007 either. So right. RTMP predates that by nearly a decade. So in terms of the way we view the internet today and internet-based content consumption today, it's kind of archaic. It's from a bygone era almost, which, for the older viewers, 20 years ago doesn't seem maybe that long ago, but in terms of the internet, it's ancient history.
Yeah, and they certainly couldn't have predicted the changes that we've seen, in how the internet has developed and how use of the internet has developed, and how live video has become such a big part of that.
Yeah.
So, it's not surprising that that kind of protocol has done us well for a period of time, but there's always a time to move on, and more modern things come to be for a reason, as you mentioned. So in 2009, we started to see Apple trying to solve other problems like adaptive bit streaming and these kind of things for on the distribution side, on the playback side, to be able to take iOS devices and stream video to them in a very, kind of reliable, that gave a really kind of excellent user experience, where there wasn't this buffering of data and all these kind of things that they had seen with previous protocols. So that there were real issues they were seeking to solve, and they solved them quite well. And then the ISO came along with a different spin on a very similar technology, and both of these protocols really heavily used the web infrastructure that had been developed at that time to ride on top of. So they are HTTP based protocols, and that makes a lot of sense. And it offered a lot of things that wasn't even imagined in the RTMP days.
Yeah, exactly. And then, as we get closer to now and into the future, we started to see that, HLS was great, but it has its, it has its pitfalls that we'll get to. And so for the larger enterprises, and especially for a lot of the more traditional broadcast media, as they shifted to doing a lot more things online and across the internet, they needed a whole different level. And High Vision came along and decided, all right, let's try to find ultimately one thing that's going to check all the boxes at the very high level. And they started SRT. And so there's, RTMP was cool in a way because it was pretty unifying. It was very cross-platform. It was, widely used. Didn't really matter what it was. But now, okay, there's 3 here, and that seems bad because now you have to maybe make choices. But these actually have distinct advantages for one reason or another.
That's right. Yeah. So they're not. I mean, you can view them as competing protocols, but in a sense, they're very complementary in some ways, and they're trying to solve different problems. And Apple came about it from their approach to try to solve their problems with iPads and iOS devices. As you mentioned, High Vision came from a completely different space, a different problem they were trying to solve. And yes, the solutions have a lot of overlap in what they can accomplish, but they were designed differently from the ground up because they were tackling fundamentally different problems.
Right. So if we kind of look at a high level comparison of some of these guys, SRT, their end goal is high quality contribution, and typically latency, being low latency as well. Their objective is to, kind of replace the old satellite trucks from news broadcast, or
Right.
get away from SDI cabling, and in some ways overlaps with NDI to some degree in those respects. Um,
Right.
Apple, as we said, was trying to make sure that there was high reliability from a user experience on the consumption distribution side, which is, for all the things I like to rage against Apple against, that is the one thing that they do well, is that as an objective they deliver. It has drawbacks, as we'll get to, and one of them is latency
Yeah.
is extremely high. And then MPEG-DASH from ISO basically went, okay, well, we want to solve this too, but in a more open standard. Do what HLS is doing, but open source, open standard. And so they basically went in and tried to tick all the same boxes, but totally open. And so latency is a big one, right? Because RTMP, from a latency perspective, was actually pretty good.
Yes.
Where some of these other ones are worse in that regard, but they have a bunch of other features that make it better, as we'll see.
Yeah, and I think the Apple approach was very much to say, let's trade latency. Let's deal with applications that can tolerate latency and make the user experience for that very, very good,
Yeah.
right? And that's what HLS does so well, is that user experience of playback. It's smooth, it's seamless, it works really well. What they used to enable that was they traded latency, and they said, okay, we're going to tackle the applications where latency is not so critical and make sure that is a great experience for watching video. As you mentioned, SRT was trying to get in a different kind of realm, and they didn't want to necessarily dictate that the user trades latency for that quality, and so they came to different ways of doing that.
Yeah. So looking at this chart, and another thing that I guess when we were talking about this content and talking about what we wanted to really share with you guys, latency has become a huge subject in terms of the live streaming world, and partly because people want as low a latency as possible, and to some degree they're under this delusion that zero is possible, and to some degree it could be someday, but certainly not today. And there's a lot of things that come along with that in terms of risk, and that's why Apple took their approach. And realistically, people seem to also forget in a lot of the conversations that I have is that your typical television broadcast has latency, and part of it's intentional, so that they can bleep things and whatever. But there is always some latency there as well. It is not zero latency. It is not actually real time. And the fact that we're talking about protocols now like SRT that can be lower latency than your television broadcast is pretty significant from a technology standpoint. So breaking this down here, you can see on this chart, HLS can range somewhere between 15 and 45 plus seconds of average latency. And that's big. For certain use cases, that might not be acceptable. Dash is a little better, but pretty similar. Yeah. RTMP sat in a very middle ground between could be very low, could be as much as 30 seconds. And there was a lot of factors that went into that.
Right.
Things like RTSP, even WebRTC, which is what a lot of video conferencing tools are built on and things like that, kind of under that 5-second mark. And then SRT's goal, of course, is to be sub 1 second. That's kind of a big thing. And it's actually very possible with SRT, which is amazing. And so I think that's a big reason why it's definitely in that future that future use scenario because of what it's capable of from a lot of perspectives, as you'll see when we break that one down. Yeah. So maybe let's take a look at Dash in a little more detail. So again, dynamic adaptive streaming over HTTP, big mouthful. So as we mentioned, it was developed by MPEG and ISO as an open standard, codec and resolution agnostic. So it's essentially a wrapper that is agnostic to what you pack into it, which is great. That's a nice thing to have. It means it's very flexible. And it was basically just built to solve a lot of the inherent problems of RTMP as we started to recognize that it wasn't serving a modern context with RTMP anymore. HLS, as we said, very, very similar, but specifically developed by Apple for iOS devices. And a lot of that had to do with not wanting to use things like Flash, which was very much hand in hand with RTMP from beginning all the way up till recently. But also, not wanting to necessarily buffer on the player hardware side on the iOS devices because they designed them to have very minimal RAM and things like that to actually buffer this stuff. And they didn't want to use the resources of the hardware to buffer it. So they essentially created something that buffers it on the encode side instead. So there's some good quality that comes out of that, but extremely high latency. So one of the things that people are moving away from RTMP for is they need more modern solutions. So these two both can replace RTMP as it kind of goes out. One of the things it does, as you mentioned, Dave, riding on HTTP means that it's actually cheaper and easier for CDN, a content delivery network, a service provider, to deploy these because there's less transcoding typically involved in order to move it for things like adaptive bit rate on the distribution delivery side. That's a pretty big win for those service providers. Also, because of that, HTTP means it plays nicer with firewalls and proxies and all these other kind of things that are now a reality that may not have been 20 years ago in the same way they are now.
Yep. Yeah, and they've inherited a lot of the things underneath because they're HTTP and all the way down as security for TLS and underlying things for HTTP advanced. These protocols just pick that up because they're riding right on top of that. So they inherit a lot of that underlying technology that's changing going forward. So it was definitely a good choice to fit into the kind of ISO stack at that layer and say, okay, we're going to use HTTP as our base, and everything below that we're going to inherit as it grows and changes. And that gave you the firewall capability to pass through a lot more easily, and continued to evolve without them evolving their protocol. That protocol would just inherently evolve as HTTP evolved. And that was definitely a good thing.
Yeah, we can also pack a lot more information in there that RTMP was never designed and is not really capable of supporting. Some of the ways that's important right now, and we've certainly seen that in this most recent history. Things like multiple audio tracks to support multilingual live streaming, inclusion of closed captionings or embedded advertising, and ultimately, not so much on the encoder contribution side, but on the distribution and delivery side, DRM support, to protect people's copyrights and so on. These are things that RTMP could never do. It literally cannot carry them. And although we didn't put it in this list, you could extend that to even more modern and future compression codecs as well. That they just don't fit inside RTMP. And so something had to give in order to support all of these objectives that everyone is trying to achieve. HLS Dash and SRT can do all of these things, which is pretty amazing.
Yeah. And as you mentioned off the top, we're really at Epiphan, we're really concerned with the encoder to ingest point. And a lot of what these protocols are solving are more on the distribution side, but harmonizing that protocol from all the way from the encoder to that distribution point has a lot of advantages, especially for things like these multilingual kind of applications and things. The more that can be brought all the way back to the source where the encoding is being done and the content's being created, the better. And that's why, even though the motivation for these protocols was not strictly on the ingest side, it makes sense to bring them to the ingest side of the equation, because that harmonizes the service right across from content creation all the way to the viewer.
Absolutely. So we're going to take a look at a little bit of SRT. And, again, because of our focus of being the contribution encoder going up, this is maybe the most exciting one to us, partially because it has some things that are unique to it as well. Definitely an alternative to HLS and Dash for better ingest, but focused, slightly different problems. Low latency being a big one. It's still firewall friendly, which is awesome. And ultimately, it's also secure. It's right there in the name: secure, reliable transport, SRT. And that's critical. It is also open source as well, like Dash, and is essentially, there's a huge growing ecosystem community of companies that are involved, including Epiphan, that are part of what's known as the SRT Alliance, that are all participating in this. And it's really exciting to be part of that. So SRT, this is a pretty traditional workflow. I think most people are used to looking at a chart like this in terms of stream publishing. You have your encoder. We're using the Pearl Mini in this scenario. Then you're sending a stream across the internet to your destination, your CDN, your streaming server. That's what RTMP does now. But the biggest thing that SRT really adds to this equation is that second dotted line coming back to the encoder. And that's diagnostic and packet recovery information. And this is where the reliability comes in. That's something RTMP didn't have. RTMP literally just kind of chuck it over the fence and hope for the best. That was pretty much all you got. There was no error correction. There's no, feedback. It was just, here you go, good luck. And so they wanted to make sure that there was other layers to this. And in the modern context, that's pretty important.
Yeah, the other protocols really relied on more traditional transport mechanisms like TCP or just UDP, which has no packet recovery whatsoever. And that had its advantages in terms of simplicity and using what already came. But SRT's real reason to be was to remove that portion and say, let's do better for live streaming, especially at a distance. Let's make a protocol that's built directly for that rather than reusing the underlying layers so literally. And that, is what really separates SRT from the others, and makes it a unique kind of protocol on the ingestion side.
Yeah, but don't just take our word for it. Some of the examples of the ways that we're already seeing SRT being used, totally invisible to you, the viewer, but very recently, SRT was being used to deliver the live feed for the NFL draft not long ago. Big tech companies like Microsoft use SRT now to stream large events as part of it. NASA uses it to distribute live video across different control rooms for monitoring and a bunch of other information. So this isn't just us saying all of these things. This is already happening in the real world, and being hugely beneficial already today. And of course, the other way that we can do it, and one of the big focuses for us adding SRT to the Perl family of encoders, is beyond just that simple, ingestion method. We also have kind of, I guess, layers to that ingestion if you want.
Yeah, we're adding the ability for not only for the Perl to be able to send SRT up to a streaming server or a CDN, but also for Perl to receive SRT. And you mentioned the ecosystem is growing quite rapidly. There are SRT cameras, there's software that'll allow you to stream with SRT. So having those SRT sources on a kind of production level allows you to move that production point from the source and be able to take in multiple sources that could be geographically very diversely distributed, bring them all into one central point, do your production from there, and then continue from that point, which in our diagram here is the Perl 2 that's aggregating a stream from a Perl Mini, and then maybe you're doing your graphics and other production and other elements there, and then you can stream to a CDN, again, either using Dash or HLS or SRT to get to your destinations.
Even RTMP,
or
if that's
RTMP,
what...
absolutely. Yeah, so this just allows you to bring in that remote feed into your production over a protocol that really is designed to move live video over a variable network, I'll call it. You still want a good quality network, but you can definitely make the trade-offs you need to accommodate the network that you have. And if that Perl Mini in our example here is sitting, as it is in our case, at someone's home, or you're bringing in a remote guest lecturer from somewhere, you don't always have the luxury of having a brilliant internet connection, and SRT is really great for helping you manage that connection and be able to kind of stack that, as you said, kind of stack that ingestion, do your ingestion once to a new production point, and then ingest from there to your distribution.
Right. And as you mentioned, this graphic's talking about doing that across the internet from site to site, which is definitely what Haivision really had a big part in mind with looking at how they wanted SRT to work, was linking multi-sites and stuff like that. But even just internally to your network, SRT has some overlap with things like NDI, where you could use multiple devices within the same network aggregate and go back out. So instead of using NDI cameras, we're starting to see a lot of those camera manufacturers add SRT directly to the cameras as well. So, I'm not going to choose a preference. I think they have different pros and cons to both of those, and SRT versus NDI is maybe another throwdown we might have to address in the future. I think there's some big pros and cons to both. But, just allowing this, and certainly what we've seen for the past 3 months and what we are seeing as, um, you know, going forward into the new normal future, if you will, this kind of remote production, remote contribution is gonna continue. It's not going away.
Right.
If you will, the cat's out of the bag. Everyone's now on it, and the evolution of this stuff is accelerating at an incredibly rapid pace. And you're not putting it back in. It's just go here.
Yeah, and this very much comes from a broadcast kind of architecture and workflow where you're bringing in remote feeds and then you're going to do the production at a more central facility. I think of something like a sports venue where they're bringing in the live sports, then they're going to cut to a studio where guys are talking through the intermissions, and then they might bring in a remote feed from a match or a game that's going to start in a couple hours. So mixing these contribution feeds and doing that production and then distributing out from there is very much a common broadcast workflow. The big changes that used to be done, as you mentioned at the very beginning, through satellite trucks or dedicated SDI runs, or it was a very expensive, difficult endeavor. And really, SRT's mission was to get rid of that satellite truck, get rid of those expensive satellite links, and say, let's do this over the existing public internet with SRT and enable that same kind of flexible workflow that you can bring in lots of sources from anywhere, but you don't have to deploy, a satellite truck or a dedicated
Exactly.
fiber link or SDI link in order to be able to do that.
Yeah. And I mean, the other thing we should mention that I think is actually really cool about SRT is Haivision does have something that they call SRT Hub that allows you to do dynamic routing essentially remotely in the cloud, if you will, into a one way to look at it. If you have a huge ecosystem of different devices and you want to change where they're pointing, there's a lot of cool underlying tech with SRT. And I think considering, we recently joined the SRT Alliance, and although we've been asked for the past couple of years, I guess, about joining,
Yeah.
we didn't pull the trigger until recently because there wasn't a ton of momentum. But the momentum behind it now is so incredible,
Yeah.
that it's like I mentioned, it's accelerating so rapidly that it's a fantastic time to be involved with that ecosystem.
Yep.
One of the other things, of course, people are going to ask about is in terms of remote contribution. Um, you know, People have definitely the past little while have been using things like Zoom, as we have been, or Teams, or Skype, or WebEx, or whatever. We can run down the list of every single web conferencing tool to do these kind of remote contribution things. One of the things that SRT can really help with is improving the quality of that.
Correct.
And despite the fact that we use Zoom to do this, we're doing it right now, in fact. Um, it's not ideal. It's not the best quality. The only real advantage to it is the real time two-way communication of it. But aside from that, it is no one's idea of ideal video quality or audio quality, not even close.
Right.
SRT has some options to address that and improve it and make it better from both video and audio. So I think we have a little bit of a comparison we're going to do with you, Dave, between your Zoom shot and something you're pulling from a Pearl you have in your home using SRT.
Yeah, so I'll just bring another mic in here. I've got this connected up. So I've got a Pearl Mini here at my house. And I've got my camera split. It's going both into Zoom and it's going into my Pearl Mini. And then I've got my Pearl Mini streaming SRT to our Ottawa office. So you can see on the right-hand side, that's the SRT feed. The other one's the Zoom feed. And hopefully you can also hear the quality difference in the audio as I've got this microphone connected directly into the Pearl Mini, which is then going over the SRT link. So it really does increase the quality of the contribution. And, in the broadcast world, that's been something that's imperative for a very long time. But now we're starting to see how do we bring that down to all kinds of broadcasts and all kinds of streaming technology. And this really enables that, allows people to up that quality of the contribution that they're using and, leverage that and not have to sacrifice it using something like a conferencing environment to bring that video in. So I'm going to flip back to the side here where I can speak with George a little more easily.
Yeah. So, it's funny because just before we started, we were talking about, what is the sun going to do with the weather we've been having today? And I've been noticing the clouds passing your window have been
Yep.
making the lighting in your room go crazy, which is fine. But some of that actually may have helped highlight things in the sense that, one of the things that Zoom doesn't do well, of course, is it does a very high level of compression. And with your background that you have with that gray and some of the lighting you sometimes get in there, the artifacting for the keen-eyed is pretty noticeable. And when we were playing with those side by sides, I don't know if any of you watching could tell, but over SRT, where you can control the bit rate and really fine tune it. Same thing with the audio. That artifacting's gone, and you can, Werner was just saying in chat here, Zoom in quality, laugh out loud. Exactly. I mean, for the most part, you can make Zoom look very good. I'm using a good quality camera into Zoom. Webcams are usually the weakest link there, but even then, Zoom does overcompress, especially on audio. And so something like SRT, where you can pack basically whatever you want into it, high bit rate, high quality audio, whatever you need, really, really opens it up quite a bit, which is fantastic. And Werner also mentioned off the top that he's a user of a Pearl 1, the original Pearl EV, which is awesome. Glad you're enjoying it and still using that. And he said to the Pearl family, as a quote of quoting me, and saying that he likes that. And yes, indeed, the firmware release that's going to be coming shortly that will include HLS-DASH and SRT support. That firmware release is 4.12, is coming to the Pearl 1s, Pearl Mini, and Pearl 2. All kind of hardware generations of the Pearl family are going to have this update and be able to support these protocols. Will the original Pearls be able to do as much SRT as Pearl 2 can? No, but that's a hardware performance thing. But it will have it. And so that could be really exciting for some of you people having still using some of that older hardware, which is really exciting for us as well. It should help get some more life out of those older devices for sure.
Since we did the announcement just the other day, I've had a few people reach out and ask about beta loads, whether people can get testing. There's a lot of people really anxious to try SRT. We were part of the Plug Fest that the SRT Alliance hosted, I guess, almost 4 weeks ago, maybe more. And that went really, really well. So that allowed us to really interop with a whole bunch of players that have added SRT to their products. And that was great. We are looking for interesting use cases. If people are doing kind of remote production feeds and want to jump in and try SRT and get going with it before our official release, which is still maybe 2-3 weeks out, we are looking for people to do some unique testing. So if you think you've got a unique scenario and you're keen to try it, do contact us at info@Epiphan, and we'll redirect your request to the product manager, who can see if yours is a case that might be interesting for both of us to jump in and test with. So if you're in that boat, do contact us. We'd love to talk to you and see if there's some testing we can do together.
Absolutely. So if anyone has any questions about SRT, HLS, Dash, let us know in chat. We're happy to answer those. But otherwise, I hope you've enjoyed this summary. We're very excited about adding more protocols to the Pearl family and really being able to expand those ecosystems and increase that interoperability between different things. And it's an exciting time in the live streaming world. And there's a silver lining to a lot of things. And if maybe this is slightly selfish, but one silver lining to all this pandemic stuff is that what may have taken a year plus in some regards in terms of the streaming world has been accelerated into the span of about 3 months. And as a technology provider, that's very exciting for us. We're really seeing a a huge increase in interest and use and experimentation and new ways of doing things. And it's all
Absolutely.
really
Yeah.
cool.
Yeah. We see people in every industry innovating right now to try to adapt. And
Yeah.
that's really exciting. As you said, it was probably, we saw it happening anyway, but certainly not at this pace. And this has been a
Right.
huge catalyst to move those decisions along and get people jumping in and trying new things. So it's a very exciting time from a technology point of view, and trying to see, how can we provide video products and services that can
Mhm.
help move that along faster and help bring kind of that video experience better and better to the home, to the office, whatever, so that
Yeah.
restrictions on travel and other things are not quite so terrible.
Well, as one of our engineering team has often said, or our head of engineering is quoted actually saying in one of our promotional videos about the history of Perl, the democratization of video, right? I mean, ultimately, that's what our objective is to try and deliver that to as many people as possible in ways that make sense, and that's trying to get that. So let me just take a look, see if we had any questions here. There was a question here from Nick on Facebook, I think.
Yeah.
Maybe some of the key differentiation advantages between SRT versus over NDI. The biggest one there to start with is that SRT is internet routable. NDI really isn't. That's certainly the biggest one. So if you're talking strictly on an internal network, to some degree, NDI might actually have the edge to a point if you have a super reliable internal LAN, partly because NDI is auto discovery. It just auto populates. You just click and add it. Pretty straightforward. SRT is a little more manual. You do need to know IP addresses and ports and these kinds of things. But it'll traverse a firewall and it'll traverse the internet and go site to site while being encrypted. NDI is not encrypted. So there's pros and cons depending on what your workflow is. Certainly on an internal LAN, to me, I think NDI might still have the slight edge, as I said. But externally, does not even comparison. SRT is by far the winner there. The other advantage I would say, and what some people may have noticed, the latency difference between your Zoom feed and the SRT feed when we were playing with that, Dave, is that that's actually configurable within SRT. You can choose the buffering, which will impact your latency. There's basically no other protocols that really have that level of control. So if you're on a particularly weak network and you're worried about packet loss, you can increase your buffer manually to whatever level is going to be acceptable. And I think you mentioned earlier you were running at about 300 milliseconds by choice.
Yeah, when we set it up, we just chose a latency that we thought would work over the network. I'm at home and my network is not super stable. It can change from day to day, and who's in the neighborhood and what they're up to. So I am over a shared infrastructure here. So I chose what I thought was a safe value. I think if you're looking at comparing it to something like NDI and you're in a more closed network, certainly you can crank that latency down much tighter than that and get very, very low latency. But SRT is fairly unique in giving you that option to be able to tune the network the way you want and say, okay, I have a long round trip time, or I have a significant packet loss in the network that I'm going to. Let me tune that. Whereas the other protocols, including NDI, will rely on existing protocols that were really built more for file transfer than for live video. And so that's one of the key differences. So I think you're right. If I was in the same kind of network and I had lots of bandwidth and I know my packet loss is very low because it's a managed network, then NDI is a great choice.
Yeah.
Anytime you're not managing that network and you're not sure what you're going to get, or you need encryption, or you're going over a longer distance, then you really start to look at SRT as being a better alternative.
Absolutely. And Linda was mentioning in chat, they need something you can slap on the back of a movie camera. It's, a lot of movie shoots, television shoots are trying to figure out how to physically separate people, especially cameras, in all these COVID times. And Werner was just saying that already exists. And he mentioned one, and it absolutely does. And it really depends on what your workflow is. It's not really on topic for today, but want to answer it anyways. if we're talking about creating a local network of wireless cameras at a professional level, things like the Teradek equipment for directional wireless stuff is awesome and is a fantastic way of doing that, and can be very long range. If your budget allows.
Yeah.
But he was mentioning some other ones with 4G uplinks and yeah, there's lots of ways of doing that stuff as well. It's just a question of what your objective is and what you're trying to deliver, but that's definitely nothing new. But the other thing, of course, is SRT. If you have cameras that are connected just to a network over SRT, feeding those back to an encoder like Pearl, they don't have to be close to each other. They could be far away. They could be across the internet. Doesn't really matter. So those can be big advantages too with protocols like this. And Warner also commented, as we were saying, NDI over a WAN? Nah, exactly. It's just not, especially not regular NDI. HX, I'm sure you could do, but then you need VPN, you need all these other things. But yeah, regular NDI over a WAN, no chance.
Yeah, and when we look at what NewTek, I mean, NDI was developed by NewTek, and the problem they were trying to solve was, let's get rid of the SDI router that sits inside of the studio, right, inside of your own network. Let's replace that and get rid of those SDI cables and do it over an internal network that's IP based. And so that's the problem it tries to solve. SRT is trying, as we said, to get rid of that satellite truck that's feeding things that are remote to the building. And so, they do have different behaviors, and they're tackling slightly different problems. And in some scenarios, you could substitute one for the other. But if you think about where they came from, it gives you a pretty good idea. High Vision's trying to solve one problem. NewTek was trying to solve something else. So that's generally how I would recommend you think about the two protocols when you're trying to decide which one to go for.
Exactly. So we are running a bit long here. We're going to wrap up. Werner's last comment there was being able to send out multiple streams to multiple endpoints is one of the big features of the Pearl. Absolutely. And with SRT, you would continue to be able to do that, just like with RTMP. Essentially, you're just trading, RTMP for SRT in that scenario. You can still send that out. So, that's going to be, some very cool things. And Werner's just saying, is there a way to switch Pearl SRT ingest? Yeah, so we can dive into that at another time if you want, or if you want to discuss that offline. Send us an email, Werner. We can dive into that. But yes, you'll be able to bring in an SRT feed as an input, as well as being able to do an SRT as a published output on Pearls. So it'll have both of those options, which is great. And of course, you can do that with NDI on the Pearl 2s. SRT is going to be coming to all three models, which is awesome. So that'll do it. So thanks everyone for joining us. We are going to next week be talking about adding guests to your live stream. We've done this before, but we wanted to update it, partially because there's these newer technologies out there, and there's a new way of thinking about how we do this in all these crazy pandemic times. We also have webinars coming up, including diving into some of these more subjects, next week. So check out epiphan.com/webinars for past and upcoming episodes. And as always, we're here 3:00 Eastern on Thursdays for Live at Epiphan, where we're discussing all kinds of different topics. It's funny, I have a note here that I'm guessing is just a form letter, trade show promotion. There aren't any of those, so we're not going to promote those. Those have all been canceled throughout the rest of 2020, essentially. So if you weren't already aware of that, and you were maybe hoping at seeing us at something like IBC, that's not a thing. Trade shows are closed for 2020, maybe 2021. Who knows? That's one of the areas where these protocols are making a difference. People moving it online. So very cool. Thanks so much, Dave. Thanks everyone for watching. Thanks everyone for your questions and comments. And we will see you next time. Thanks so much.
Take care.